All right, welcome viewers. Welcome back, 2022, first video. We are broadcasting live from Studio 301. We have for you today a unit on on right triangles. We are going to be learning special types of right triangles. So in the previous lesson, we learned about Pythagorean Theorem. Phone should be away. We learned about Pythagorean Theorem, which is if you have two sides of a right triangle, and you're asked to find the third side, you can use the Pythagorean Theorem, c squared equals a squared plus b squared. However, sometimes you don't always have that information. And so there are two types of special right triangles that we have to memorize these relationships, and it makes a lot less work, okay? So we're gonna start with the 45, 45, 90 triangle. We know that the sum of all three angles in any triangle adds up to 180. Right? Is everyone on slide? I think this is 17, right? 17, okay. So 45 plus 90 adds up to 180, okay? So, and we know back from unit 5, that if we have two angles that are the same, the base angle theorem says that the sides opposite those angles are also the same. So these lengths are the same, that's why we have them labeled X. All right, so now, if we use Pythagorean Theorem, and I'm going to do that for you in the next example, we will find the length of the hypotenuse using the lengths of the two legs. However, if we know this shortcut, for every 45, 45, 90 triangle, the relationship between the lengths of the legs and the hypotenuse is times the square root of 2. Then we don't have to go through all that work, okay? I'm going to show you one example with all that work, but then we're just going to use the shortcut for the rest of the time. However, if you sometimes are given the hypotenuse rather than the length of the leg, what's the opposite operation of multiplying by the square root of 2? What's the opposite operation of multiplication? Division. So to go from the leg to the hypotenuse, we're going to be multiplying by the square root of 2. And to go from the hypotenuse to the leg, we're going to be dividing by the square root of 2. And that's a little bit trickier because when you divide by a square root, sometimes you have to rationalize the denominator, which we're going to do today. There's another type of special right triangle that we have to memorize relationships for, and that's the 30, 60, 90 triangle, which will come after this example. So now we're going to go to slide 18. Okay, so here we are given a right triangle. We are given the lengths of these two legs are both 7, which makes these angles both 45 degrees. Because if these lengths are the same, the angles opposite them are also the same, which makes them each 45. Are you with me? Okay, so now that we know it's a 45, 45, 90 triangle, if we know the shortcut, because it's special, we know the hypotenuse is just 7 times square root of 2. Done. If we use Pythagorean Theorem, which I'm going to show you now, and everyone is writing this down, because this is a unit that we really need to take good notes in. So, and we're not going to do this every time. We're just going to do this for this one example, because we've got a shortcut. C squared equals a squared plus b squared. And we put in our 7s for A and B, which we already know how to do. And we get 49 plus 49, which is 98. I know I'm going fast. Once we get here, we then take the square root of both sides. And now that we have learned or reviewed how to simplify radicals, we're not going to use a calculator to do the square root of 98. We are going to just simplify that radical. And we already know that 98 is 49 times 2. 49 is a perfect square. So C equals, I'm going to break this 98 up into 49 times 2. This is a perfect square that's going to come out. And look, We got the same exact answer. 7 root 2. So rather than, is everyone writing this down? Paper's fine too. Rather than go through all this for these types of problems, we're just going to memorize this relationship. 7 root 2. Done. Questions? Still writing? Can I move on? Okay, slide. Where is my mouse? Here it is. 19. Okay. First thing we look at is we see, oh, I forgot to tell you guys about my find at my thrift shop. Look at this jacket. This is an Olympics team jacket. Have you ever seen one of these in real life? No, nobody's seen one in real life, only on television. I have one now. Thrift shop. You cannot beat this thrift shop, I'm telling you. Okay. Now we're given the hypotenuse and we're asked to find the lengths of the legs. We know that they're the same because these angles are 45 degrees, which makes the sides across them the same. So to go from the side to the hypotenuse, we are multiplying by the square root of 2. So the opposite operation to go the other direction is divide by the square root of 2. So it's just 4 divided by the square root of 2. And that's the answer. However, we cannot leave the answer in that format. We're going to have to, there's a radical in our denominator, and we know what to do. I know it's been a bit. Does anyone remember? What? Yeah, we are going to multiply by special 1. In this case, is root 2 over root 2. And everyone is writing this down. The reason we are doing this is because when you multiply across, you get 4 root 2. And then what's root 2 times root 2? Root 2 times root 2 is root 4, right? Which is, what's the square root of 4? Done. We're almost done. Now we just have to simplify that. 2 goes into 4 evenly. So this is just 2 root 2. And I don't think it's asking for a value of x or anything in this particular problem. It's not. What's the length of the missing side? It doesn't even say what the missing side is. Good times. So the length of both of those sides are 2 root 2. Good? How are we doing? Are you guys so excited to be here today? Y'all, I have 267 viewers. I mean, not viewers, subscribers. It's amazing. Okay, next type of special right triangle. This one's a little bit more complicated because the lengths of the sides are not exactly the same. We have a short side, a long side, and a hypotenuse, okay? We learned back in Unit 5 that when we have a smaller angle, the side across from it is smaller. And we have a bigger angle, the side across from it is bigger. Yes? So we have a 30, 60, 90 triangle. 30 plus 60 plus 90 adds up to 180. Okay, so the short side is across from the 30 degrees because 30 is smaller than 60. And the long side is across from the 60. And then the longest side, which is the hypotenuse, is across from the right angle, like usual. So we have to memorize 2 relationships. Everything revolves around the length of this short side. The short side times the square root of 3 gives us the length of the long side. So if we're going from the long side to the short side, we will be doing the opposite operation of multiplying by the square root of 3, which is dividing by the square root of 3. To get the hypotenuse from the short side, we're just multiplying times 2, or the other direction, dividing times 2. Dividing by 2. Some people get that confused because the 45, 45, 90 triangle is times the square root of 2, but this is just a regular 2. It's always easiest in these examples, in these types of problems, when they give us the short side, because everything revolves around the length of the short side. For example, in slide 21, everyone go to slide 21. Notice, most of the time in these problems, they only give you one of these other angles besides the 90. So they told us this angle is 60, which makes this angle 30. Are you with me? Okay. 30 is the smallest angle, which means that the short side is across from it. In this case, they've given that to us. It's 8 inches. I mean, yeah, we could do Pythagorean theorem here, couldn't we? It's a right triangle, and we're given 2 sides. So we could do additional work and do Pythagorean theorem and find the length of the third side. But if we know the shortcut relationships, we can just multiply or divide and be done. So, okay, short side is 8. The relationship between the short side and the hypotenuse is just times 2, which is where the 16 comes from. The relationship between the short side and the long side is what? Times, what's the other relationship? Look back at the previous slide. Do we need to do jumping jacks? You guys awake? What's the relationship between the length of the short side and the long side? Here's the short side. Here's the long side. What did they multiply to get the long side? This x times what gives us the long side? So that's what we're going to do. We're just going to take that 8 and multiply it by square root of 3. Done. What is the length of the missing side? 8 root 3. Is there a place to write it? All right, I'll just write it down here. 8 root 3. No work. No work. And this comes in very useful also in pre-calculus, at the very beginning of pre-calculus. So this is important, and you'll see it again. You'll forget it, but then when you see it, you'll remember, because you're like, oh yeah, Helbing taught us that back in January of 2022. We have a video to prove it. How long is this video so far? 12 minutes. Not bad, not bad. Let's go to the next one. Okay, this is the most difficult type of problem you're going to get for a 30, 60, 90 triangle. Ready? Okay. 60-degree angle is right here. That makes this 30, and that's 90. This is a 30, 60, 90 triangle. It's special. We know the relationships. The 15 is across from the 60. So what length is that 15? Is that the short side, the long side, or the hypotenuse? It's across from the 60. Sorry, I can't hear you. I hear someone saying something. I just can't hear what it is. It's the long side. Thank you. Okay, so we're given the long side. We need to find the short side, which is over here, this y, that's across from the 30. So we are going to have to, from the short side to the long side, we multiply by the square root of 3. So we are going to have to divide by the square root of 3. So I'm going to do that down here, and make sure you don't get the x and the y confused. We're going to start with y, which is the short side. So I'm going to write y equals 15 divided by square root of 3. And that's the answer. We just can't leave it like that. What do we have to do? Yep, special one. In this case, you are right. It is root 3 over root 3. We're getting somewhere. What's root 3 times root 3? Done. Let's look what we got here. We're almost finished, but 3 goes into 15 evenly. So we're just going to simplify it, and then we will be finished. And I'll just write that down here. 5 root 3. There we go. There's our y. How are we doing? X is a little easier because the relationship between the short side and the hypotenuse is what in a 30, 60, 90 triangle? Here's the short side. Here's the hypotenuse. What are we multiplying the short side by to get the hypotenuse? Times 2. This is only for 30, 60, 90 triangles. It's special. So if the short side is 5 root 3, we're just going to multiply 5 root 3 by 2 and be done. So I'm going to write x equals, and I'm just going to write 2 times 5 root 3 just so we can write it out so everyone remembers what we're doing here. 10 root 3, done. That's the hardest type of problem you're going to get when they give you the length of the long side, because you have to divide by the square root of 3, and then you have to rationalize the denominator, and it can get kind of messy, and you have to simplify. How are we doing? I got 1 thumbs up. I got 2, 3 thumbs ups. I think we're done with this video, and we're going to keep moving on in class. All right, thanks for watching. Make sure you subscribe.